Hello viewers, in today's lecture we are going to study the equation of a line in space. Now in space we mean that we have to find the equation of a line in 3 dimensions, right? In our earlier classes we have studied the equation of a line as y equal to mx plus c. Now this is the equation of a line in 2 dimensions, right? The same line can also be represented as ax plus by plus c equal to 0, and this is known as the general equation of a line in 2 dimensions, right? So viewers, we have also studied the other forms of the equation of a line. For example, we have studied this form. This is called the intercept form, right? This is called the slope intercept form, right? And this is the general equation of line, right? Similarly, we have seen x cos alpha plus y sin alpha equal to p. This is called the normal form, right? So viewers, we have seen the various forms of equation of a line in 2 dimensions, right? Now in this lecture we are going to study about the equation of a line in 3 dimensions, right? Now we know that a line is uniquely determined if either it passes through a given point and has a given direction, or if it passes through 2 given points, right? So the a line can be uniquely determined if it passes through a given point and has given direction and the second one is that if we know that the line passes through 2 given points. Now viewers, here first we will take this case, right? If the line is uniquely determined if it passes through a given point. Say a point is given here. Say this is a point A through which a line passes. Suppose the line is like this. This is the line, right? Say this line is L. Now this line A L passes through the point x1, y1 and z1, right? Okay, so it passes through a given point and has a given direction. So by direction we mean that this line L is parallel to some vector B, right? This is parallel to some vector B. So L is parallel to the vector B, and this vector B can be written as we can write it as AI cap plus BJ cap plus CK cap, right? Now let P be a general point on this line L, right? Then we join OA and OP, right? So OA is say vector A, right? So this is the vector A, and OP is the vector R. OP is the vector R. So what we have here, what information we have here? We have a line L. It passes through a point, given point A. The coordinates of this point A are x1, y1, z1, and the position vector of this point A is OA, that is vector A, and P is a general point on this line L, and the position vector of P is OP, that is vector R. Right? Now if we apply the triangle law in this triangle, that is if we apply the triangle law of vectors, we have OA, vector OA, plus AP vector is equal to vector OP. Right? Now we can rearrange it as vector AP is equal to vector OP minus vector OA. Now here's this line L is parallel to vector B, right? So this implies that this vector AP, the vector AP is parallel to vector B. Clear? This vector AP is parallel to vector B. So therefore AP can be expressed as a lambda times of vector B, where lambda is some scalar, is some real number or some scalar. Now if we put the value of vector AP as lambda times B, here we have lambda B is equal to OP is vector R and OA is vector A. So therefore vector R can be written as A, vector A plus lambda times vector B. So viewers, this is known as the vector equation, of a line in space, right? Thus the vector equation of a line in space is vector R is equal to vector A plus lambda times of vector B. Clear? Now here in this vector equation, this vector denotes the point through which the line L passes through, and this vector B represents the vector the line is parallel to. Clear? So vector B is the vector to which this line L is parallel to. Clear? So here we have parallel to line L. Clear? So this vector represents the point through which the line passes, and this vector B represents the vector to which this line L is parallel. Viewers, this vector B gives us the direction ratios of the given line L. Right? So this line L has the direction ratios which are given by the components of the vector B. Clear? Now let us take an example. Now here let us take this problem. we have to find the vector equation of a line which passes through 5, 2 and minus 4 and parallel to the vector 3i cap plus 2j cap minus 8k cap. Now here the line passes through this point. So A is the point A is 5, 2 minus 4, right? So the vector A, this vector A is 5i cap plus 2j cap minus 4k cap, right? And this is the line, and this line passes through this point 5, 2 minus 4, and this line is parallel to the vector B, that is given by this vector. So here the vector B is given as 3i cap plus 2j cap minus 8k cap. So therefore we can write the vector equation of the line as this is vector R. So we have vector A as 5i cap plus 2j cap minus 4k cap plus lambda times vector B, and vector B is given by this vector, that is 3i cap plus 2j cap minus 8k cap. So this is the vector equation of this line. Clear? Now viewers, let us find the Cartesian equation of the line. Now viewers, we have already seen that if we have a line L which passes through this point A and parallel to this vector B, then its vector equation is vector R is equal to vector A plus lambda times of vector B. Now from by using this vector equation, we will now find the Cartesian equation of this line, and let us see how can we do this. Now we have vector R is equal to vector A plus lambda B. Now vector R can be written as xi plus yj plus zk. Clear? And here for vector A we can have x1 I cap plus y1 j cap plus z1 k cap, right? Plus lambda times vector B. We have seen that vector B is ai cap plus bj cap plus ck cap. So here we have ai cap plus bj cap plus ck cap, right? Actually A, B, C are the direction ratios of this line L. L is parallel to vector B, and drs of, always remember this is a very important point, drs of line L are A, B, C, right? So A, B, C are the drs of this line L. x1, y1, z1 is the point through which the line L passes through, and xi cap plus yj cap plus zk cap is the general point on this line L, right? Now let us simplify this expression. So we can write it as x1 plus lambda a, x1 plus lambda a times I cap, then we have y1 plus lambda b times j cap, and then we have z1 plus lambda C k cap, right? And here we have xi cap plus yj cap and zk cap. Now viewers, if we compare both the sides, or if we compare the components of both the sides, so we have x is equal to x1 plus lambda a, because the x component here is x and here the x component is x1 plus lambda a. Similarly, this y is equal to y1 plus lambda b, and z is equal to z1 plus lambda c. Clear? Now from here we can also write x minus x1 is equal to lambda a, y minus y1 is equal to lambda b, and z minus z1 is equal to lambda c. Now from here we have x minus x1 upon a is equal to lambda, we have y minus y1 upon b is equal to lambda, and we have z minus z1 upon c is equal to lambda. Clear? Now we see that all these expressions, that is x minus x1 upon a, y minus y1 upon b, and z minus z1 upon c are all equal to lambda. So all these expressions are equal to each other. Clear? So we can write therefore we have x minus x1 upon a is equal to y minus y1 upon b, and z minus z1 upon c equal to lambda, right? So viewers, this is the Cartesian equation of a line. Clear? And the vector equation is this. So we have derived here two forms of the equation of a line in space. The first one is the vector equation, which is given by r vector is equal to a vector plus lambda times vector b, and the Cartesian equation is x minus x1 by a equal to y minus y1 over b and z minus z1 over c. Clear? Okay. Now sometimes we do not write this, so the Cartesian equation of the line is given by this equation. So let us take an example. Suppose suppose a line passes through say minus 1 and 2 and parallel to the vector say I plus j cap or 2j cap plus 3k cap, right? Then find the vector and Cartesian equation of the line. So what we will do, so here we are given the point, so here the line passes through this point, so we have x1, y1 and z1 as minus 1 and 2. Clear? And the line is parallel to this vector, so here we have 1, so the vector b is given as 1i cap plus 2j cap plus 3k cap. So therefore the drs of the line are 1, 2 and 3. these are the DRs. So A, B, C are 1, 2 and 3. Clear? These are A, B and C. So the equation of the Cartesian equation of the line can be written as we have x minus x1, so here we have minus 1 divided by 1, then we have y minus minus 1 divided by 2, then we have z minus 2, this is z1, this is 2 divided by 3. Now this can be written as x plus 1 over 1, and this is y plus 1 over 2, and then we have z minus 2 by 3. So this is the Cartesian equation of the line. Clear? Now we have to find the vector equation. So the vector equation can be calculated, or it can be determined by this equation, a plus lambda b vector. So here we have vector r, and vector a is it can be written from using this point. So we have minus I cap minus j cap plus 2k cap plus lambda times vector b is I cap plus 2j cap plus 3k cap. So this is the vector equation of the line. Now viewers, let us take some illustrations here, and these illustrations will be very useful for solving the problems related to the equation of a line in space. So here I have taken the equation of a line, right? Now if we compare this equation with the standard equation, that is x minus x1 over a, y minus y1 over b, and z minus z1 over c, we see that this line can be written as now x minus 0. This can be written as x minus 0 divided by minus 2. Then we have y plus 2, so this can be written as y minus minus 2 divided by 4, and then we have z minus 3 over 1. So now what are the conclusions? What are the conclusions? So the first conclusion is that this line passes through the point 0, minus 2 and 3, right? So this line passes through the point 0, minus 2, 3. The second conclusion is that the DRs of the given line, this line, given line, are minus 2, 4 and 1. So these are the DRs, right? And the third point is this line is parallel to the vector. Which vector? The vector b, and this vector b is given as minus 2i cap plus 4j cap plus k cap. Clear? So these are the important conclusions which can be drawn from this equation of line. Clear? Now viewers, now I am changing the equation of this line, and I am writing a new equation here, and the equation is say 2x minus 3 divided by 1, and then we have 4 minus y over 6, and let us say here we have 3z minus 1 over 5. Clear? Now let us draw some conclusions from this equation, and here we can have the new conclusions. So we can rub it. Yes. Now see, here we have this line. Now the standard form of the Cartesian equation is this form, that is x minus x1 over a equal to y minus y1 over b and z minus z1 over c. Now this equation is not in the standard form, so our first aim is to express this equation in this form, right? So before attempting any question related to the equation of a line, we must first change the equation of the line in the standard form, and if it is already given in the standard form, then we can proceed further, right? Now let us change this equation or express this equation in this form. So what we will do, I am doing it here, so we'll take 2 common. See, we'll have 2 times of x minus 3 by 2, then we have 1 here, and this is 4 minus y, so we can write it as minus 1, and y minus 4 divided by 6, and then we have 3z minus 1, so we'll take 3, and here we have z minus 1 by 3 divided by 5. Clear? Now see, this equation can now be expressed as x minus 3 by 2, and this can be written as 1 by 2, taking this 2 to the denominator of 1, and here we can write y minus 4 divided by minus 6, taking this minus sign to 6. Clear? And then we have z minus 1 by 3 divided by 5 by 3. Clear? So viewers, here we have expressed this equation in this form, and this form is similar to this standard form. Now if we compare these two equations, see, this line passes through the point, so the point is 3 by 2 comma 4 comma 1 by 3, right? Now the drs of the given line are half minus 6 and 5 by 3, right? Because the drs are given by a, b and c, and here a is half, b is minus 6 and c is 5 by 3. But if we look at this equation, we can readily say that a is 1, b is 6 and c is 5, but this will be wrong because this equation is not in this standard form. So our first aim is to express this equation in this form. Now this line is parallel to the vector b, and vector b is given by half I cap minus 6j cap plus 5 by 3 k cap, right? So these are the conclusions. Now viewers, let us take this problem. The Cartesian equation of a line is given by this equation. So this equation is x plus 3 by 2. We have y minus 5 by 4 and then z plus 6 by 2. Now if we compare this equation with the standard form, that is x minus, sorry, here we have x minus x1 divided by a, y minus y1 by b, and z minus z1 by c. Clear? Now x1 is equal to minus 3 here, y1 is 5, and z1 is minus 6. Clear? Comparing these two equations, and a is 2, b is 4, and c is 2. So therefore the vector equation is vector r is equal to vector a plus lambda b. Then we have vector r. This vector a is given by this point. Clear? By this point. So we have minus 3i cap plus 5j cap minus 6k cap plus lambda times vector b will be given by this by these points. Clear? So we have 2i cap plus 4j cap plus 2k cap. So this is the vector equation of this line.